Good morning, good afternoon, everybody, and welcome to the Responsible AI for Ukraine Spring 2025 Project Showcase. We all know why we're here, right? This is the second showcase of this particular cohort. We started the projects in the fall. I will start, as usual, with a very brief overview of the program. My name is Julia Stojanovic. I am an associate professor of computer science and engineering and of data science at New York University. And I also run a center here called the Center for Responsible AI. And RAI for Ukraine, as this program is called, is one of the flagship programs of our center. You can find more information about the center at this link, r-ai.co. And just very briefly, what are the goals of RAI for Ukraine? This program has been running for 3 years, and the goals haven't changed, unfortunately, because the political situation really hasn't changed. So our goal is still, first and foremost, to provide a sense of normalcy and research opportunities to students who are studying in Ukraine today. It's also great to be able to provide mentorship opportunities to graduate students and postdocs who are participating in this program from around the US and Western Europe as project mentors. And in the long run, our goal is to make it so that Ukraine is much more competitive in AI and responsible AI in particular. So to build research capacity in Ukraine in AI and responsible AI. The structure of the program, as you all know, is that we start with a new cohort in the fall. We solicit project proposals from mentors. So if any of you watching this would like to mentor a team of students, please write to me and I'll tell you more about the process. So we get project proposals sometime in August, and then we run an open house where mentors pitch these projects and students learn about them. And then they decide which interviews to go to see which projects they would then join. And then in the fall semester, students work in teams on the projects of their choice, and they receive academic credit. There is a showcase at the end of the semester. And then for the students and mentors who would like to continue working together, they can do this for the following semester, the spring. And at that point, students receive stipends for their participation. And then some of the projects will also continue into the summer. So this is something that I will want to know from all of you at the showcase, as well as in the days following up, whether you want to continue over the summer, because there may be a paper that you're still working on. So we'll discuss that. And just some quick statistics. We launched in June 22. So far, we have had 71 students from 12 Ukrainian universities participate in the program as RAI for Ukraine Fellows. 48 mentors from 23 academic institutions in 8 countries have participated in the program. And this spring, there are 10 projects that you all worked on, and we will learn about your progress and your future plans during the next hour and a half or so. And now let me hand over to Yaroslav to say a few words.
Thank you very much, Yulia. Hello, everyone. Yulia mentioned that the program started 3 years ago with the goal of giving Ukrainian students a sense of normalcy. I think that Yulia, the program, and you personally gives not only a sense of normalcy, but you empower our students. And I would like to thank you for this, because indeed I see the growth of those students. Every year, the program becomes much bigger. Now it's global. I see students graduating from this program go for their graduate studies for really top programs in the world. I see those students go to PhD programs. I see those students go to some university positions. For example, just last week, our university decided to hire one of the program graduate as a specialist on AI to bring instruments for our university, of course, responsible AI instruments to make our work more productive. So I really see not only number of students, number of mentors, but also see really the impact of this program for every students who participate, and I hope for every mentor in terms of papers, conference presentations. And I hope we'll soon see this globally and particularly in Ukraine as an economic impact of this program. So thank you very much, and I wish everybody great presentation and great results. Thank you.
Thank you very much, Yaroslav. I'm really thrilled to hear about this, and I didn't know that, in fact, you are hiring program graduates, so it would be nice to connect a bit later to find out more. Tanya Zakharchenko is the program coordinator and is really, one part of the heart of this program. And unfortunately, she couldn't join us today for personal reasons. But I just want to acknowledge her contribution to the program overall, as well as to the work this semester. So now let's dive into project presentations. The way this will be structured is we will give 5 minutes to every team to present a brief summary of everything that they've done on this project and of their future plans. And we will leave 2 minutes for Q&A. And Tanya is not here to help me keep track of time, so do please watch the time yourselves so that I don't have to multitask too much between the timer and the slides. And when you need the next slide, just tell me, I'll advance it. And so the first team is going to be Virni Flow, and Nazar is here to present this work. Please, Nazar.
Yeah, hello. Can you hear me well?
Yes.
Okay. Hello, everyone. My name is Nazar, and together with Denise, we are glad to present our project supervised by Julia. Unfortunately, Denise can't join today, but I will present alone. So we are presenting Virni Flow design space for responsible model development. This project builds on the foundation of our previous projects in the research program, and we have developed over several past years. And of course, we are very grateful to Julia for her support and guidance throughout this journey. And firstly, I will remind you the motivation of this project. It stems from the multi-objective nature of the most real-world ML tasks. For example, in hiring and recruitment, fairness is just as crucial as accuracy. Similarly, other tasks as those in healthcare or self-driving cars prioritize stability as a key objective within the ML pipeline. And second, some objectives such as fairness cannot be automated, which have been discussed in multiple academic papers over the last decade. And the human domain experts should be involved in defining what is good model performance depending on the context of use. And the third, model development spans various stages like pre-processing, null imputation, fairness enhancing, and it requires extensive experimentation to reach the desired objectives. Therefore, responsible model development is an iterative process that takes a lot of time and resources. And finally, most of AutoML system fails to achieve all of this. Next slide, please. Yeah, and to tackle all these challenges, Virni Flow incorporates the following system architecture. The process begins with a user providing an experiment configuration, including all pipeline components, objective criteria, and optimization strategies. Next, the task manager initializes all dependencies and generates tasks, and each task represents a physical pipeline with a specific configuration on a ML pipeline with defined components and hyperparameters. And next, tasks are to the task queue and executed by the workers. Once completed, the metrics are associated with compliance are sent to the completed tasks and the cost model updater. And the system continues to process this until the maximum time budget is achieved or maximum number of pipelines is achieved. And next slide, please. Yes, and on this slide, we are looking at the multi-objective tuning results for public coverage, and we run multiple case studies, each of one using different balance between accuracy and fairness objective weights, and plotted their outcomes across 3 different views. And you can notice that is clear smooth trade-off. As we shift weights away from the pure accuracy toward fairness, our F1 score gradually declines, while both SRD-sex and SRD-race move closer to 0. And in other words, the more samples the more emphasis we place on reducing demographic disparities, the more predictive accuracy decreases. And this plot simply lays out Pareto frontier, high accuracy configurations in one end, high fairness configuration at the other, and everything between represent different mixes of these 2 goals. And with Virni Flow, a domain expert can instantly select the exact balance they need. And next slide, please. And here we're comparing VirniFlow against Autoscalar and Alpine Meadow on 3 benchmarks with identical pipeline. And we see that VirniFlow achieves the best scores on almost every metric. Next slide, please. And on this slide, we are testing scalability by increasing the number of workers on 2 datasets. Unlike Autoscalar and Alpine Meadow, which are both limited to a maximum of 32 workers on one node, VirniFlow can scale up to 128 workers across 4 nodes, enabling us achieve to rough speed up, 5 times speed up on Folk employment and 7 times speed up on hard dataset. And the last slide one, please. Yeah, and our future plans are finalizing a draft about VirniFlow and submit it to LDB26 scalable data science track. And next slide. Yeah, and thanks for your attention. If there is time, we are happy to take any questions.
Yes, great. We have time, so please, any questions? Maybe to say that this work builds on several pieces of work that we've done over the course of the program. And Denise, who's not here, has been with the program from the very beginning. And we have another paper also that is going to be presented at VLDB this year, called Shades of Null. That is the result of an earlier project on which this builds directly.
Yeah, with this project, we try to extend the architecture to use multiple workers and speed up results, for example.
Yeah. So this is inspired essentially directly by the previous work, right? Where we knew that we needed to speed things up, and that's why we decided to work on this. Siham, I see you unmuted, yes?
Yeah, can you comment a little bit more about the workers? You know, that when you were showing like look, how do you identify, these different workers? You know, how do you sample them from somewhere? I mean, just to get a sense of, you know.
Yeah, for example, the user set up like possible models, null indicators, fairness interventions that they want to use, and some objective metrics, for example, like F1 score and SRD, and give them weights, for example, like 0.50% for the fairness and 50 for the accuracy. And then next system, like sample a set of physical pipelines, we are each executed by each this worker, because why we also need use, for example, because we have multi-step pipelines. For example, we cannot train a model before we do null imputation, and task queue tracks it all, and then we also update our cost model and like give more promising physical pipelines, which are probably give our better results based on some Bayesian optimization.
So K is not fixed, right? It's something that's derived from the goal that the user states?
Yeah, you set up your maximum time budget or maximum number of pipelines you want to relate.
Oh, I see. So the user defines K, right? It's not something that's derived from some target value of fairness or... Right?
No, this K may be like, it is not explicitly set up, but through the time, like this time component. Because we can execute a very large number of pipelines, but we should somehow to not to run it overall. Yeah.
And this is the impact of the number of workers, right? That's
workers,
the parameter.
Yeah, for example, like I said, Alpine Meadow and Autoscalar and some other prominent systems, they are like can work only on one node with 32 workers, and we like extend this problem so we can run much.
I mean, the reason I was
of workers.
Yeah, the reason I was asking is that you could turn it around and decide how many workers you'd need to achieve a particular target speed up or target, but it's a different problem.
Yeah, but definitely related. Good idea. Maybe that's a follow-up.
Good.
Yes, thank you. Yes.
Great. So let's move to the next project, and this is on participatory design of entity relationship models. Victoria will present.
Thank you. Hello, everyone. And today I'm going to present an update of this project. Next slide, please. Our work during the semester aimed to improve and polish Onion framework. Onion is the model that represents a structured approach to incorporating participatory design into entity relationship modeling. It moves from broad general ideas to well-defined and strict ER model. Today, we are going to present conducted case studies, key observations, and outcomes. Next slide. We have organized the workshops and feedback sessions with 3 main research questions in mind. Firstly, is Onion usable and applicable at all? Secondly, if Onion can produce a usable and technically correct ER model. And research question 3 asks if Onion support an inclusive data modeling environment. Does the produced ER model capture vital information and contributions from participants? The next slide. So, 2 organizations participated in our study. Donor.ua is a well-known platform designed to make blood donations easy and safe, along with reducing stereotypes around it. UKU Volunteers Lab is an organization helping UKU students join various volunteering programs, making an impact on their society and building leadership skills as well. The next slide. In the Donor.ua study, we had 2 teams with 6 people in total. Teams were divided based on participants' experience in such way, so one team would always have one inexperienced participant, in this case, the one who have never done blood donation before, one experienced blood donor, and one person associated with the Donor.ua organization. In our case, it was CEO of Donor.ua for one team and an experienced volunteer in another team. The next slide. So this case study was done online by using collaborative platform Excalibur. Even having same objective, both teams produced similar but yet different models. One was reflecting volunteer role in the system, and other was focusing on the technical details of the whole blood donation process. The next slide. Volunteers Lab study was from the other hand done on site at UKU. We used pen and paper to sketch our ideas and keep track of the conversation. So on this photo you can see the result. And the next slide. After the Onion workshops were done, we have conducted feedback sessions with unstructured interviews and encoded answer in order to understand the trends. Participants generally found Onion to be intuitive and accessible, even for those who had no previous experience in data modeling. All mentioned that the use of live visualization improved their comprehension. Participants reported that understanding developed progressively through the session. The environment felt safe and encouraged open sharing. The next slide. We also conducted cyclic technical validation step to process normalization stage of the framework. 5 participants were asked to validate the ER models iteratively and then evaluate if provided Onion artifacts and schemas were useful for them during this validation. The next slide. We observed that input from non-obvious stakeholders, like non-donors, revealed blind spots and added depth to final ERDs. Splitting participants into small balanced teams helped surface varied system views and manage authority imbalances. Very interesting thing, at least for me, was to detect these invisible and background entities. This is like a source of external influence, like institutions. For example, for Volunteers Lab, it is UKU, which help shape the system but are not represented in final entity relationship model. This highlights the need for context-aware modeling. Even with the same system goals, participants produced different models in different teams, which showed how background and framing can affect the interpretation. The next slide. We want to conclude that Onion supports inclusive data modeling based on participants' feedback. Onion artifacts help it with technical validation step, Workshop resulted in created ERDs covering selected participants' perspectives. And the unexpected outcome, which was noted by most participants, is that they gained certain perspective shifts by better understanding the other side and people with different experiences. For example, like donors and non-donors. And the final thing is that I'm super grateful and honored to share that Onion paper has been accepted to Hilda workshop. And this wouldn't have been possible without help and support of my mentors, Julia and George. I'm truly thankful to the program and support from Responsible AI Center and Eindhoven University for this opportunity to present work at the workshop and engage with the community. So our next steps is to prepare full paper and continue research in direction of human-centered data representation. Thank you.
Thank you, Victoria. So Victoria is going to go to Sigmund, actually, to the Hilda workshop. Questions, comments? We have a couple of minutes.
Okay, so this is super cool. So so you showed like this effort that they were doing on paper, but was there also, I guess there was also an online system, right, where they could they could work together. I wonder, you know, how much the fact that there is an online system, I mean, how much of a difference it makes as opposed to you know, working together on paper.
Yeah, it's totally different because people shared that online they needed more time to start engaging because it was like less you are not close to each other and it's not clear how everyone feels. But when we had it on site, it was like almost instantly we started drawing and we had much more output information compared to the online session. But we understand that in real world scenario, most people are online, connected online, and they will probably use online tools.
And if there is no other question by someone else, I have another question.
Please do.
Okay, so there is quite a bit of work, obviously, in like team formation and then choosing, you know, people. And I could see that, you know, diversity played a role in what you have. But there is also like, you know, communication between the, you know, what's the communication model, right? Like, do you have a moderator? Are people all considered as peers? I imagine in your case, they were all peers and they could do anything, anytime.
We have a specific role of the facilitator, which we aim to have to be this person, but who is not like interrupting anyone. Facilitator's goal is to set up the process, explain what we are going to do, how to do it, but people should, we expect so people collaborate and figure out things by themselves because facilitator can direct. And if facilitator starts using the words which are shaping and framing their process of thought, it creates already like not the result that we want. So we want people to try to do as much as possible without interrupting them.
Okay, so it's sort of this just helping people make sure there are no hurdles, right? Okay. Anyways, there's a very interesting paper. I'd be happy to share it with you about also all kinds of you know, team dynamics, right? The size, there's a critical mass, the size of the group, and it'll be interesting to see if what's been observed elsewhere for very different tasks, collaborative editing, for instance, of text, is something that you can observe in your context. Really cool.
Yeah, that would be great. Thank you for the questions, Siham. All right, so we're moving now to the next presentation, and this is Model Explain, exploring the quality of explanations under model multiplicity.
Yes, so hi everyone. Me, Bogdan, and our mentor Laisa have been working on a project called Model Explain, and today I want to talk about what we've done during this semester. Next slide, please. So you can remember this picture from the previous semester and imagine one more time that you apply for a loan and receive, next slide please, an unfavorable decision. You ask, what could I change to get approved? And actually, next slide, Counterfactual explanations answer this. But for example, if the bank's model updates tomorrow, those recommendations might not longer work. Next slide. And next slide. And next slide one more time. Okay, so standard counterfactual explanations assume that the model is fixed, but in practice, many models can explain the data almost equally well, a phenomenon called a Rashomon effect. And we define a Rashomon set as all models whose loss is within epsilon of the optimal model. Our goal is very simple, is to produce the smallest change of input that guarantees a positive outcome in every model in Rashomon set. In other words, find a single action one can take with confidence, no matter which near optimal model the decision maker uses. So we came up with our own counterfactual method called Alice. And I want to briefly talk about how to find a reliable counterfactual explanation. So the first assumption that we have to make is that our loss is convex. So we work with logistic loss here, which is convex, and we can approximate it using ellipsoid. And without loss of generality, we will discuss for linear models, but we can generalize it to neural networks, for example, if we do linearization on the last layer. And actually for neural networks, the Rashomon set is infeasible to find, so we take into account only the embedding space. And directly searching for every model in Rashomon set is intractable. Instead, we approximate the Rashomon set using an ellipsoid and using the Hessian of the loss, which is convex. And that gives us actually a very nice closed form solution for the worst case prediction. And we can use this theorem to kind of quick check the robustness of given explanation, which we use in our method. And actually, next slide. Alice comes with 3 theoretical guarantees, which is uniqueness, that the objective is strictly convex, so there's only single best counterfactual explanation. Stability, that a small change in original input leads to a small change in recommended recourse. And alignment, because we use ellipsoid and we know its principal directions, so the solution lies with the principal directions of uncertainty cached by the Hessian. Next slide.
So about results, both on linear models and or neural network, we perform on par or better than any other method. Why? Because other methods probably they assume some unrealistic properties about the model, for example, about the loss landscape or something like that. And there is like second group of methods that just use some sort of heuristics, and it doesn't really work for like unstable cases or for like larger neural networks. And furthermore, if they use MILP, like delta robustness and so on, it's like it has exponential working time with increase of model weight space. And meanwhile, we are extremely fast. Next slide.
Okay.
And we are extremely fast. Like on most of the data sets, we achieve speed up to like 700s. And furthermore, we are robust because like we do exactly what we claim we do, and it works. For linear models, we have like optimal solution because for linear models, if we have like MSE loss, its Rashomon set has exact shape of ellipsoid. If it's logistic loss, locally it has shape of ellipsoid. For neural networks, we can just work on embedding space. So, and we can like look at the graph and, for example, see like L2 distance influences robustness. And overall, there's interesting trend that there is inherent trade-off between like distance, proximity, and robustness. And it's like same for all methods. And just the question is which method achieves like 100% robustness first, or if it even achieves 100% robustness. Next. Thanks. And next. And next slide, please. So there should, yeah. So basically our method is faster, much faster. It's more robust, and we have theoretical guarantees. And we finished our paper and submitted it today to NeurIPS. So yeah, about plans, probably we can like develop our theoretical framework, and maybe we can switch to recommendation systems, or even try something new.
Very nice. Congrats once again on submitting the paper.
Thank you.
And let's see if there are questions. Also, I think we have approximately kind of a critical mass right now of people on the call. Maybe if I can ask everybody to turn on their video so that I can take a photo of us as a group. And then you can turn off again if you like. So everybody who's on right now, if you could turn on your video, thank you very much. Hi, Noha. Okay, let me start taking photos. We can take a few. Take one more. All right, and maybe we'll do it again at the end to see if we might have more people. Okay, meanwhile, you all have had a chance to think about questions, so please.
I can come up with one.
Thank you, Sihem.
So is this like independent from the model itself? Like, because you said you wanted to extend this to recommendation. Clear to me, like how much, how dependent is this on the underlying model?
Basically, the only thing we need is that like a last layer being like dense layer or some sort of encoding embedding space. So if we have that, we can apply our method. So for example, it is not applicable for decision trees. We need like continuous models. Neural networks, general editing models, anything. LLMs.
An algorithm to find Rashomon set itself, so we can apply it here and make a robust counterfactual.
Other questions? Okay, if not, let's move to the next presentation. And this one is on aligning knowledge graphs with large language models. Please go ahead.
Hello, everyone. We're team KJLLM. Can you move to the next slide? Yep. So what the problem is about? So generally, a knowledge graph is like a structured representation of facts where entities are nodes and relationships between them are edges. And aligning refers to mapping entities from one knowledge graph to equivalent one in another. And it can be issues like synonyms or minor structural differences. And global matching is the process of finding all possible correspondences across two distinct knowledge graphs, aiming like for a consistent alignment between them. Okay.
More about pipeline. Ontology alignment system is a program that gets input ontologies and produces output mappings. So ontology alignment system, in our case, LogMap, can operate both in automatic mode or allow interaction with an oracle. So the oracle is like the system that works as a language model and produces mappings in the cases of uncertainty. On the right side, you can see the image how exactly the prompt builder works. Next slide. So our dataset consists of 3 parts. We use anatomy, BioML, and large biodatasets, or all of them are biomedical. So data types consist of the triplets, which have subject, predictable, predicate, and object. On the right side, you can see how exactly example of this kind of data looks like. Next slide. So in our prompt builder, we selected templates, 6 of them. On the left side in the table, you can see that each template has some specific categories. Some of them are natural language friendly, some of them are with extended context, and some of them have synonyms. Here you can see natural language friendly with synonyms prompt. And next slide.
Yep. So we used the GPT-4o mini model with a family of Gemini models. So all models were accessed through the API, where our common limitation was rate limiting and the cost of the API itself. To correctly extract the answer for the LLM, we used structured output, where decision of model was represented as Boolean. Next slide. Yes, so our evaluation included comparison of all models with all possible prompts. Our hypothesis is what is more valuable, the model itself or the prompt. We also investigated whether the system prompt impacts the metric, and we did evaluations in terms of how much our LLM helps the LogMap system as a whole. So the input to the LLM was pairs where LogMap was not sure about his decision, and LLM helped to make it. As for metric, we used the F1 score and the Yodlet index. And Yodlet index is sensitivity plus specificity -1. It is a popular metric in the field of medicine, which our datasets are about. This metric is good when we care about the true positive and true negative rate. Next slide, please.
So now let's move to the results. First of all, we compare the static performance with and without Oracle. So here we can see that on the table, the columns were the just automatic system without any extension, and different oracles for example, Gemini models. And on the right plot, we can see the rattle plot where we compared the performance of our Oracle SLM system with some other oracles that were simulated, something like Oracle with some error rates, and on average we can see that our Oracle performed close to that one with error rate close to 20. On some dataset it performs better, on some worse. And on the next slide we can see that different datasets and different tasks have different performance as on average and as on the top experiments. And for example, here we can also compare the performance of our Oracle and ontology alignment system on that reduced task. And we can see here that yi index of the ontology alignment system is close to 0. On the other hand, our results are more than 0.5. And on the next slide, we can see that after running a lot of experiments, we can see some kind of patterns that can be differ for different models, different data types, different tasks. And after analyzing it on the next slide, we can see that in terms of the models, the Gemini Flash 2.5 performed the best. The difference is quite significant. And in terms of the prompts, we have tested different prompts, and on average they show close performance. But the prompt that Dmitro was shown on the previous slide performs the best. It's the prompt with natural language and synonyms, and it shows something like better performance in terms of 1-2%. And on the next slide, we can discuss some other insights that we've seen, something like intellectual impact. So we do not only provide the data in the prompt, but also some instructions to the model. We tested with some instruction and without, and different types of instructions, something like basic, some of which are just more focused on the ontology or more on synonyms or on the lexical part. And we do not see some significant value in different types of system prompts, but providing some of it performs better than without any system prompts. And about the determinism, we can see here on the left heat map that the experiment shows the close results, and the difference is quite low, something like 0.01. So it does not affect the performance. And also we've seen that pattern parallelization and some caching and some optimizations show the better performance in terms of time and as cost efficiency. So we can run a lot of more experiments with some cheaper costs and in less time. And on the next slide, we can discuss our stand and plants. So we have submitted our papers this week to the ISWC conference. And about some other conferences we can target is the same one in the next year, or the ESWC, that will be something like in half a year. And about our future work, we can define some key points. One of each is enhancing system performance, something like LLM exploration, Oracle ensembles, prompt engineering, and impact on the other ontology alignment system. As the other type of plans and the work is something like data insight, so we can extend the contextual data information and probably use some RACs additionally to test it. And the final part that we can test is optimizing the cost and performance, so we can trade off how much questions do we ask and how does it affect the system at all. So that's all. So we can move to the questions.
Thank you very much. This was a little longer, but it's a larger team, so I think that's fine. We have time for a question or two.
So I didn't get, or I didn't follow what you meant by aligning. Like, is the alignment, does it have to be like exact, or do you allow some approximation, or in your, yeah.
I can answer this question. It's not necessarily exact matching. So we have like two different ontologies, and they may have different information, but we want to match some entities that are as close as possible.
And
basically,
when
that's the same entity, but it can have some little different name in the other knowledge graph, or little different property, but that's as well, it's the same entity.
yeah, and when you're using the language model, do you ask it to give you an explanation of what it's suggesting?
No, it's only binary output if they're equivalent or not.
That would be interesting though, right? To actually get an explanation.
Yeah, because then you could sort of get a better sense of, yeah, and even quantify it, right? That explanation. Okay. Cool.
Other questions? Anyone? If not, let's move to the next presentation. And this one is on causal Shapley values for causal interpretability.
Yeah, so hey everyone. So my name is Maxim, and together with Joshua Loftus and Sakina Hansen, we've been working on the topic of causal Shapley values. So next slide, please. So I'd like to start from a problem setup and the motivation. So the Shapley values is a method for finding the contribution of each feature to a model prediction while not having access to the model itself. So however, there could be some challenges when we have some feature interconnected, and accounting for that may lead to a better explanation, especially when we have a more complex data when the number of features grow. Next slide, please. Classical Shapley values have to satisfy four fairness properties: efficiency, null player, symmetry, and additivity. I won't go through all of them, but we might want to keep an eye on the symmetry, because in the case when we have X1 and X2 feature, and both of them impact the prediction, we might want to have a different attribution based on the direction of error between them. So in the causal versions of Shapley values, this property is usually relaxed. And also want to keep an eye on a value function, which is denoted as V, which generally can be interpreted as a value score for a set of feature in its values. And that is function, it generally determines what type of Shapley values is that. So next slide, please. Yeah, so some of the classical approaches is a conditional Shapley value, which uses conditional expectation inside the value function. And the recent researchers proposed a causal Shap, which uses interventional distribution under the hood. These two approaches has its trade-offs, and we have been investigating on these differences and trade-offs in our previous work. So yeah, next slide, please. Talking about our most recent work, I'd like to start from a bit of a background. What is generally a CATE, or conditional average treatment effect? It generally measures the expected difference in outcome between the treatment and the control for individuals with specific characteristics. It offers kind of a local explanation of a treatment effect. Yeah, next slide, please. Another reason why we are interested in this is because collation-wise effect of conditional Shapley values can be decomposed into weights. First weight, which generally says of how much the sample is an outlier, and this Kate. So this kind of bridges a gap between the Shapley values and the more common notation which is used in causality. Yeah, next slide, please. Let's look at a simple example where we have a placebo treatment which is impacted by status. This way, treatment is confounded by the status. If you want to measure an effect with conditional Shapley values by taking average of collation-wise effects, we may get non-zero value. And it happens generally because of this first case. I use notation of pause here because it's not a true causal case. And the reason for that is that because we're trying to find an effect of T, but we do not really control for confound this S. In other words, this problem comes from the treatment assignment bias. So where our treatment is not randomized, but there is rather something else from inside our data that impacts whether we got this treatment or not. Next slide, please. This generally leads us to the idea of propensity weighting and the propensity weighted Kate. So the propensity weighted Kate is generally an estimator used to compute the conditional average treatment effect when we try to adjust for this treatment assignment bias using special propensity weights. Yeah, next slide, please. With that being said, we propose a new PyShap. We generally uses propensity weighted Kate to compute the Shapley values. So a bit of a mess is going on here, but I generally pointed out the main difference in the formula, and that's a difference in the weights and the way we compute this outlier probability. Next slide, please. We have started investigating the differences and the trade-off of new proposed approach. As you can see, it generally gives a conceptually different results. So it generally tells us the different stories, and it's worth to say that it's not really necessarily better approach, and it may be, and the one approach may be desired over another depending on the specific use cases. Yeah, so next slide, please. Proposed approach has a fundamentally different way to account this causal and affect from comparing to the fundamental causal Shapley values. We still use a conditional distribution where we try to adjust for a treatment assignment bias using these additional weights. However, there is still work to do to understand how the difference, how to understand when each Shapley value is suitable and where to use each of them. Thank you. I'll be happy to answer any questions if there is any.
Great, thank you. I have questions this time. So how do you think about evaluating these methods for usefulness to somebody to do something with? Are your experiments, for example, on synthetic data, or is there a use case that you have in mind in particular?
Yeah, so we will try to work on some specific use case, some which are very intuitive. For example, like the most common is like a kind of treatment where the person got a treatment and it really got better, and try to think of what explanation we get from this approach and whether it makes sense and for what case it might make sense. So that's kind of a lot of examples and a sample of them.
So make sense is like to a human intuitively, right?
Yeah, so all of this is generally made for human, and it's generally not only for kind of a human understanding, because there's other approaches which is kind of wrapped around. So it's kind of a framework around the Shapley values, like counterfactual Shapley values or rational Shapley values, which generally try to find, for example, what shift we can do in our sample so that we would get desired outcome, and that's where some of the approaches might be desired over another just because of the way they attribute. So there's a couple of differences, and it depends generally on the use case.
Yeah, I mean, it's a difficult question, right? I don't actually think that anybody has a satisfactory answer to this. Like, what are explanations good for, and how do we know if they're any good? What was your favorite part of this project? What did you learn that speaks to you the most?
I really like to play around with the formulas. So generally, that was very interesting to go around from the code to the formulas. So that's what I enjoy personally.
Nice.
Thank you.
Okay, thanks very much. Any other questions?
Just in terms of the time it took to compute those values, like is there Any bottleneck anywhere, knowing that SHAP values are expensive to compute?
Yeah, generally they're expensive to compute, but real numerous number of estimators, and generally all the approaches can be considered quite equal time with those estimators. So that's not a big difference that we want to capture here.
Mhm.
All right, thank you very much, Maxim. Let's go to the next project, and this one is on safe hierarchical classification.
Hello, everyone. So first of all, I have to present our team. It's team of 4. So my name is Mikhailo Blashny. I work with Anna Poliva, and we have 2 wonderful mentors. It's Michael Benedict and Zoltan Bori. So let's jump into the problem. So there is well-known multi-level classification problem where the model's task is to predict set of correct classes. But in this research, we try to focus on constraint multi-level classification problem, where the goal is to predict of set of classes, but these classes should satisfy some constraints over the output. And there is line of research that tries to solve this problem, like CSAN tries to add some extra layer to the model, some base model, make its prediction coherent with the constraints. It also allows to train with it. And also there are some other approaches like quasi-logical relaxation that add constraint satisfaction score to the loss and make the model backpropagate and learn from that as well. Actually, there are many more sophisticated approaches that build this constraint inside the model, but the goal of our research is try to investigate what's the benefit of sequential model, what's the benefit of learning conditional probabilities instead of marginals. So next slide, please. So the previous time we experimented with different types of architectures, different models that can give us this whole joint probability distribution. And we understood that the best model was 2-stage architecture that consisted of base model and sequential model. So let me explain what this means. So base model produces simple marginal probabilities over each class. So it's the model that solves the problem in the most straightforward way. And there is some stacking model, it's called sequential model, that reads this sequence of marginal probabilities and produce conditional probabilities of the next class. So this way we can model a whole joint probability distribution. So next slide, please. So so let me give motivation why we have to solve this basically harder problem, why we have to calculate these conditional probabilities. So on this slide, played with the real toy data set where we have only 2 classes and 1 constraint. And here we can see that our sequential approach actually can better capture the underlying data distribution. We fix the same model sizes, and from this we can make conclusions. The sequential model has a better capacity to capture the constraints in constrained space. Next slide. So that was a small data set, but actually in the real world, data set is very huge. We have like huge number of classes, and we can calculate the whole joint probability distribution in a reasonable amount of time. So we had to find some way to approximate it. So we decided to apply the beam search. The beam search idea is that we try to keep k the most probable prediction on each step. And we show that actually with a quite small beam width, we can find a quite good approximation. It's around 3 and 4 that can give us very good results. And this way we was able to apply our approach to a bigger data set. So next slide, please. Okay, one table is missing, but it gives the idea that our approach is actually better in terms of accuracy than other approach on the most of data set. So next slide, please. And we also show that because of modeling this complex probability distribution, we're actually closer to correct predictions than other approaches. And our top K accuracy means that what fraction of correct prediction is in 5 the most probable answer from model. So next slide, please. Anna?
Also, another thing that we tried is to ensure that our model does not violate any of the logical constraints in the data. For that, we added such solver, which on each prediction step would evaluate if we could possibly violate something in the future, which would ensure that our model has 0 violations at the end. And this gave us the same accuracy as usual beam search. Next slide. Another question that we explored is whether we would be able to apply our two-step approach, a sequential model for unsupervised data. Because with second model, we basically correct the predictions of the first model, and this could improve quality for training this second model if you know the constraints. And as we can see, it did improve violations number. So this using unsupervised data gives us less violations, but unfortunately, this unsupervised data is detrimental to accuracy. Therefore, it is better not use it if we have very little violations. Other things that we, next slide. Other things that we had to explore is whether ordering has any effect on our second model, because it is sequential. We tried ordering by balance of labels, by accuracy of the first model, and some random orderings. And what we can see, we don't have much effect of the order. Default order and reverse order is basically random order, which is how it occurs in the data set. So it can have some effect, but there is no certain law which ordering would be the best for this. And next slide. We are also planning to go to publish to submit this paper to a conference. For this, we chose very large databases conference, which has a workshop which specifically fits our needs. It is a neurosymbolic workshop, which focuses on deduction techniques from symbolic knowledge and reasoning techniques from data. Any questions?
Okay, thank you. So yes, we have time for 1 or 2 questions.
So Anna, in terms of the inference time of your model, is it faster than beam search?
Which exactly? The one that enforces safety.
Oh no, I didn't even think about the constraints. Yeah, even like the one, you know, the initial one before introducing constraints, and then I'm assuming that adding constraints slows it down. But
yeah, it is actually slower.
Do you have a sense of how much slower?
Maybe I can just give you more detail about it. So we have 2 models. First model that produces the marginal, second model that produces the conditional probability distribution. And yeah, using a sequential model just makes it like n times longer to make the inference if n is number of classes. And introducing the beam search kind of better way to approximate this the most probable combination in joint probability distribution. So yeah, we have to pay this price of larger inference time in order to compute this more realistic joint probability distribution.
And so the reason behind asking my question is simply that I wanted to come back to the motivation for doing it this way rather than, you know, just the usual.
Yeah, so the reason why we have to, why we decided to try this approach is that we have some data set is highly constrained. There's a lot of connection between the classes, and modeling just marginals can just give us the whole way to model these interactions. And just sequential approach and actually compute this conditional probabilities give us a way to model this in a better way, less efficient, but in a better way.
And I didn't understand why the order didn't have an effect. Like you said, it's sort of regardless of, yeah. Mm-hmm.
So yeah, we produce like just each class sequentially. So firstly for first class, and second, and for third. And what we actually show that order doesn't matter. So that's a good news for us that we don't have to care about the order, how to order these classes on the most of the data set.
because you already have the target classes, right? That you want to, right? The data you're seeing is not determining the classes, right? Because the classes are given.
Sorry, I didn't get. So
I wanted to understand why the order did not matter, right? Because usually it does. In
So,
yeah, and go ahead.
what we do, we have some predictions from our base model or model one, and we correct them sequentially. So first we correct the first prediction based on constraints, and second, and so on. And as we always do it in the order, we would need to see if changing this order would make a lot of difference to how our model performs. Because, for example, one of the assumptions was, what if we first correct predictions which model one predicts better, and then based on this more accurate predictions we correct the next predictions, and we discovered that it doesn't actually make results much better, so we don't have to introduce any additional modifications to data sets and any additional orderings.
Thanks.
Okay, thank you for this discussion. Let's move to the next paper, and that paper is Maria, Guiding Teachers in Question Answer Generation with AI Planning.
Hello. So I'll be starting our presentation. Unfortunately, I cannot turn on my web camera, but you'll be hearing me. So first of all, I'd like to present our team. Those are our great mentors, Sichem and Noah from CNRS and University of Noble Alps, as well as Slava from State University and me from UCU. Next slide, please. So in this project, we work on making it easier for educators to generate high-quality multiple choice questions or MCQs. The main approach here will be to use large language models like GPT-4, but we, however, decided to use small language models like Llama 3B or Pi 3.5, since they are cheaper, can be hosted locally, and do not expose data to third parties. And overall, they give the users more control over the behavior. Next slide, please. Our work can be logically divided into two parts, benchmarking and fine-tuning. The last term, we selected a list of dimensions that can be used to evaluate how good a model is for generating MCQs. And in this term, we extended the benchmark with more dimensions and created a pipeline to evaluate any model based on that benchmark. While in the past, it would take us more than an hour to run the evaluation of a single model, now it takes less than 20 minutes, despite us having more dimensions. We ran that pipeline for more than 6 different models in different quantizations and with different temperatures, finding out that smaller models often show a very decent performance, despite having like less than 5 billion parameters. Then we formulated our results into a paper and submitted it first to data at SIGMOD, where we got rejected. So we improved our work based on the feedback and we submitted it to Dash at VLDB. Next slide, please. Next goes the fine-tuning. So we selected DPO and KTO as our fine-tuning methods of choice. And on the slide, you can see the pipeline that we use to generate data sets for both of these methods. The pipeline basically comes out to having different models generate multiple choice questions, running those MCQs through our benchmark, splitting good and bad MCQs, and then storing them for further fine-tuning. And now I'm giving word to Slava, so he can tell you more about what we achieved with this fine-tuning.
Thank you. Next slide, please. So yeah, talking about our contribution and smaller language models fine-tuning, we have built a reproducible pipeline to generate fine-tuning datasets. It includes building the fine-tuning datasets for both DPO and KTO. We also fine-tuned 3 SLM models, and we observed significant performance improvements for the fine-tuned models. It's like up to 2 times better than the basic one, and in some scenarios, it is taking over the GPT-4. And now we submitted our results in a paper, and we submitted it to Dash, and it is currently under review. Next, please. So Yeah, we fine-tuned the three models. They are Llama 3.21 billion, Llama 3.18 billion, and Gemma 2 9 billions. And also we attempted to fine-tune Phi 3.5, but the things got complicated and like the training processes failed for this model. And like our main observation is that KTO it consistently outperformed GPO on the structure quality with like 30% improvement in some cases, but DPO still shows meaningful gains, especially like where the structure and disclosure are critical. DPO shows more stable results. Then next slide, please. Lessons that we learned. They are the communication is crucial, like writing things down and clear roles. It really helped a lot. The next is that some team members thrive in collaboration, but others are most productive working solo, and that's totally okay. The reproducibility is not key, like keeping track of random seeds, environments, and data versions can save your money and time. Organizing tasks, setting priorities actually takes more time than expected. Extra compute resources won't make a bad design better, and also we learned to be selective in writing scientific papers, and it led us to split our work into 40 submissions. One is on evaluation and another is on fine-tuning, and we will share the outcomes of both as they come. Next, and we're happy to answer all your questions. Thank you.
Thank you very much. Can you say a little bit more, maybe I missed this, about evaluation? So what are the datasets tasks on which you evaluated this? And I also have maybe a not very smart question. What's a distractor?
The distractor, yeah, it's if we look at the MCQ, it has a question and 4 answer options, and there is 1 correct option and 3 incorrect, and with the 3 incorrect options, they are distractors with like it is supposed to follow some logic, but some incorrect logic that can confuse the test taker.
And these are produced by people or by LLMs, these answers?
The generation or evaluation?
So of the 4 answers that you talked about, are these human generated or LLM generated?
We have a human generated like medical notes, and based on these notes, we created MCQs.
You
with
yourself?
LLM.
With an LLM, I see. And then you checked somehow that these are actually incorrect answers?
Yeah, we like we had an additional dimension that is called like self-answerability. We checked the generated questions of like smaller language model with GPT-4 model.
I see. So GPT-4 was like the expert that was checking.
Like the judge.
I see. Interesting. And so just a little bit more about evaluation then. So what are these data sets, tasks? You said medical data.
Yeah, talking more about the evaluation. So we have this criteria that is called distractor quality, and we provide a prompt that describes this criteria, like from 1 to 5, where each like mark, it shows how good the distractors can be. Like for 1, it's very poor distractors. For 5, it's like a good distractor, and it's a good one. And
Yes, sorry, I actually wanted to know at a higher level, not about distractors anymore, but in general, what is the evaluation context for maybe both of these pieces of work, right?
Where does the data come from?
Yeah.
Also, asking.
Yeah, I can say a few words on that. So there is an institution in France called UNES, and we used basically they provide a list of let's say not like textbooks, medical articles used for students, basically, and they're split in different topics, and we call them leader sheets, and those sheets are, well, short articles on those specific topics. We have like 4,500 of them, and we use them as the input data to generate those MCQs.
And that's medical students, you said, right? That's
yes, it's primarily designed for medical students.
got it. Okay, thank you. Anybody else have questions? If not, we're moving to the next paper, and that is REST-Q.
Thank you so much. I'm so
Yes.
happy to be a part of program.
Oh, great. Thank you. Thank you both. Right, so the next paper is REST-Q, balancing resources and performance in RESTful parameterized queries.
So yeah, hello everyone. I'm glad to be here and to share the progress we made on our project with my team. During this term, I've worked with my mentors Omar, Pierre, and Balkis, who are from INRIA, France, and Mio Stab from Lviv National University. Next slide, please. Let's recall the motivation behind our project. It stems from the critical challenge faced in developing scalable databases and web applications, balancing resource consumption while maintaining acceptable quality of service. This is especially relevant in RESTful applications which use parameterized queries for secure and efficient database access. Furthermore, as AI systems become increasingly integrated into web services and backend infrastructures, they add a significant layer of energy consumption. From model training to inference, AI workloads are often integrated via RESTful APIs, using communication between microservices, application, and external systems. Cloud platforms, with their perceived abundance of resources at low cost, can exacerbate these inefficiencies through overallocation and missed energy-saving opportunities. Simple optimization or scaling strategies often overlook the complex interplay between application logic, server infrastructure, and database performance. Thus, our project is aimed to explore and address these issues. Next slide, please. In our initial research phase, we laid the groundwork for understanding the interplay between RESTful API performance and energy use. We developed a benchmarking framework with Java, Postgres, SQL using the TPCH benchmark to simulate realistic workload. While early experiments offered useful insights, they exposed key limitations we had. First one is that energy measurements depended only on one tool, Scaphandr, limiting validation and reliability of the data obtained. Moreover, the workload required extensive manual steps and data handling. Next slide, please. To address the previous limitation, we set new goals for this term, focused on making REST-Q a more robust and user-friendly, usable not just by our team, but also by other researchers studying energy consumption in cloud environments. We focused on expanding experimental coverage, streamlining the benchmarking pipelines through automation, improving energy measurement reliability by integrating Power API alongside Scaphandr, and enhancing usability with better documentation and open source readiness. Next slide.
Did I skip? I'm sorry.
Yeah. A major step forward was refining our experimental methodology. While the core approach of using predefined workloads remained unchanged, we introduced a key new features that enhance the entire process. Experiments are now defined using a structured XML configuration file, which allows easy customization of parameters such as concurrent connection, request rates, duration, and then probabilities. This added flexibility improves the usability of the benchmark and enhances reproducibility. Next slide. Additionally, our core package of REST-Q benchmark was improved. We introduced a unified JSON output format that consolidates results configuration, energy data, and container details, simplifying post-processing of the data. The TPCH query set implementation was expanded to include all 22 official queries, enriching workload diversity. We also added precise latency tracking for each HTTP request, capturing both network and server processing time to provide detailed insights into system performance. Next slide. To reduce manual effort, we develop an automated workflow for the benchmarking process. Experiments are defined in an XML file, followed by deployment of all necessary components, which includes API server, database, Docker containers, and energy monitors via an Ansible script. The benchmark client executes experiments sequentially, collecting performance and energy metrics, which are then aggregated into a single JSON output. This workflow is designed to be portable and flexible, allowing experiments to be conducted not only on Grid 5000, but also on other cloud infrastructures. Next one. To interpret the benchmark data obtained after rescue execution, one for selecting experiments and another for viewing results. Users can explore configuration and summary statistics through line, bar, and scatter plots. Next one. The tool visualizes metrics like real-time and cumulative energy consumption, comparative energy use between API and database server, latency distributions, and throughput. Next one. You missed one, I think. Okay, maybe I delete. Okay. Yeah, it was me who deleted. Okay. So we are committed to making Rescue an open source and accessible resource for the research community. To that end, we plan to release the entire framework, including the backend orchestration scripts and visualization tool, as open source. These will encourage collaboration and enable other researchers to build upon and extend the work. And next one. To sum up, this term we made significant progress in evolving Rescue from a preliminary concept into a complex, usable, and flexible benchmarking framework. We addressed earlier limitation by enhancing the experimental pipeline, expanding query diversity, introducing automation and visualization features. Looking ahead, we are planning to release and gradually add new features, while also preparing to submit a demonstration paper based on Rescue to the International Conference on Cloud Engineering. Thank you for your attention. I am ready to answer any questions if there are any.
Very nice work. Thank you. I'm really glad to see that there's energy efficiency work also as part of this portfolio.
Thank you.
Yeah, we would love to set up a time to also find out more a little bit about the project. So no concrete questions, just to say that this is very important and I'm glad you're working on it.
Thank you.
Anybody else? Students can also ask questions. You know, Denis usually does, but he's not here today. What was the most interesting part of this for you, Ostap?
I think the most interesting part was energy measurement, as this task is very actually hard because there are a lot of different instruments that allow you to do so, but to extract the meaningful information from these tools that are present is hard, but at the same time interesting. Yeah.
Great, great. All right, if no more questions, then let's go to the next project, an explainable pipeline for the automated measurement of joint space width from plain knee radiographs. Something completely different, right? We have a lot of variety in the projects. Yes, we can hear you.
Okay, so we worked this fall on the project GSV-Knee, an explainable pipeline for the automated measurement of joint space width from plain knee radiographs. On the image, you can see our team of research fellows, and team of mentors. Next slide, please. So what we did, we worked on the problem which connected with knee osteoarthritis. Why it is important and significant? Because it is really widespread nowadays. And this problem is connected with joint space width measurement. Actually, this is the main tool to assess the severity of this knee osteoarthritis, and that's why the process of estimating this joint space width is extremely important and can help to identify the severity of the disease in the patients. Yeah, and also nowadays exists a lot of gaps in explainable and interpretable solutions which work with joint space width. That's why we wanted to work in this area. Next slide, please. So what we wanted to do, we wanted to develop, train, and validate deep learning-based pipeline, which will do this task for us. We wanted also to integrate computer vision techniques and deep learning approaches to our pipeline and enhance transparency, to gain trust from clinicians, doctors, and professionals, to actually show them what deep learning can, all the stuff can make in the process of treating patients. Next slide, please. So significance, you can see here technical and clinical significance. I would just focus here on the significance of standardizing neosteroarthritis diagnosis. So in order to minimize variability among patients and also to create some tool, we wanted to create some tools for professionals, which will assist them, which will relieve some stress from them because they have a lot of work to do. And this tool may be really helpful and really show them that these approaches and deep learning based things can really help and be like the first step towards something really bigger in healthcare. Next slide, please.
So yes, about our data, we used nearly 600 X-ray images from the NIH Osteoarthritis Initiative set, and each with these 3 types of mutation: bounding boxes for localization, binary mask for segmentation, joint space and the joint space values for regression. And the next one. And for each task, we used a separate model. For localization, we used YOLO version 11 to detect joint regions with bounding boxes. And the input contains both knees and we localized joint space nerving for the next step. And for segmentation, we applied a unit architecture producing binary mask for the left and right knees. And for joint space, and for joint space measurement, we use ResNet 15 to predict joint space values. And we have 4 models in total, 1 for each knee and joint part, like right lateral, right medial, left lateral, and left medial. And the model receives the full image and predicts 7 joint space with values for the medial part and 9 for the lateral part. And the next part, and the next slide. Thank you. And also we tried to use the deterministic approach to measure joint space width, and it estimates it by the percentage of the mask. It estimates it with the percentage of the mask in the narrow vertical type aligned with the joint, and then we used a regression model to map this to map the actual joint space with values to this percentage. And the next slide.
Now moving to results. First, for localization, YOLO 11 showed very good results with mean average precision around 0.99. And the next slide, we also used EigenCam to give some insight about how this decision was made. So as output, EigenCam gives us heat map with highlighting regions that mostly influenced why this region is knee. Next slide. Then for segmentation, UNet also showed the really good results with dice score around 0.95. And next slide, also we incorporated GradCam to highlight regions of masks with biggest influence on this mask. Next slide. And for joint space width measurements, we compared the L and deterministic approaches. So as Danilo explained, we had 4 models for each knee and for each compartment, medial or lateral. And for right knee, the L approach showed better results. In this table, there is also p-values of comparison, the L versus deterministic, and for right knee, the L model showed statistically significant improvement, while for left knee, there was actually worse results in medial compartment and no significant improvement in the lateral compartment. Next slide. So talking about conclusions, our pipeline shows strong performance across both localization and segmentation stages, while for regression, the L method shows better performance on right knee, while showing quite worse results than our developed deterministic approach for left knee. But still, both the L and the deterministic approach were approved by our consulted medical experts, and So it's good to go in clinical scenario. Next slide. So for future work, we firstly have to want to evaluate the whole pipeline, because currently we only evaluated different stages. And for this, we will need new data because we have some limitations with data we currently use. Also, we need add some explainability to joint space width measurements step. And also we can expand our evaluation on more diverse population and evaluate fairness. Next slide. So about deliverables, we already submitted abstracts for this project as well as for project we worked during the fall to RS NA 2025. Also, all code is available, and we are preparing a big manuscript to Nature NPJ for this project. And finally, there is also in development mobile application, which will where clinicians will upload images of the knees, and as a result get joint space widths with also images of all steps. And finally, next slide. We want to thank you, Dr. Adolf, Dr. Johannes, and Dr. Kurt for validating our results for joint space width measurement step. Next slide. We are ready for your questions.
Thank you very much. Fantastic. Such a large body of work. Please, questions?
I have a question if I can ask.
Yes, please.
Yeah, talking about your experiments and results. So you compare DL and deterministic approaches, and why do you think, for example, for the right side, the DL approaches works better than the deterministic one?
Okay, so I'll answer. There is like currently some inconsistencies in annotations, which we worked with. That's why we are waiting for a new data, which is currently manually annotated. And this inconsistencies result that for example, for left knee, there might be some different population of patients. It can be different scales of the images, which result in like less consistent data is in training set for left models. Does this answer your question?
Yeah, it seems so. Thank you.
Other questions? If not, let's move to the next presentation. And I believe that this is the last one. So last but not least, we have designing reminiscence therapy chatbots with culturally sensitive visual stimulation for mental health.
Hello, everyone. I hope you can hear me well. All right.
Yep.
Okay, so today I present a research project guided by my wonderful mentors, Jianyuan Hong and Joan Hua from University of Texas at Austin. And next slide, please. Before we dive deep into the findings, let me briefly remind you what we implemented in the last semester. We developed Remi, a chatbot that combines conversation and 3D memory visualization to conduct reminiscence therapy sessions. This slide shows us a snapshot of Remi interface. Next slide, please. We have improved Remi in two key areas. First, we enhanced conceptual understanding by shortening the prompt and reducing hallucinations through iterative testing. We developed a plan of improving the visual memory constructions to make it more relevant. Secondly, we focused on Ukrainian language support. The chatbot now better understands and responds in Ukrainian, as shown in the before and after examples here. Next slide, please. Let's introduce the main objectives of our study. The primary objective was to evaluate the impact of visual memory reconstruction on the effectiveness of reminiscence therapy. Our secondary objectives focused on whether this effect changes depending on gender or age, and whether the duration of interaction correlates with emotional outcomes. Lastly, we included the exploratory NLP analysis to study users' open-ended feedback. Next slide. The methodology of our research. Our central research questions. Central research questions were: does adding 3D visual reconstruction improve the emotional impact and user experience? And to explore this question, we designed a study using between subject design. Each participant interacted with only one version of the chatbot, with or without memory visualization. This approach helped us reduce potential biases. Our participants were mainly students and professors from Kyiv Mohyla Academy. We chose the target group for accessibility and diversity in their background. Participants were divided into two groups, as I mentioned, and each participant completed a three-phase survey process. Pre-session, where we measured their baseline emotional state, chatbot session with guided reminiscence conversation, and post-session, where we reassessed emotional state and gathered feedback. Next slide. To evaluate the impact of the chatbot sessions, we used a combination of emotional, textual, and behavioral measurements, such as discrete emotion rating scale, called 1 to 5 Likert scale, example which you can see on the slide, analyzing open-ended user feedback, login interaction metrics, session duration, and word count. Next slide. We have recruited a total of 26 participants, equally split between the two chatbot versions. Looking at gender distribution, around 69% of participants were female and 31 male, giving us moderately gender-skewed sample. The age distribution shows that the most participants were in their early 20s, which reflects our recruitment from university. Next slide. Next, we looked at whether the conversation duration differed between different two. We looked at whether the conversation duration differed between the two groups. Results of t-test shows us that there is no significant difference in average conversation time between the groups. However, as you can see from the box plot on the slide, participants in the visual group had a slightly higher mean conversation duration, while non-visual group showed us a wider variability. Next slide, please. On this slide, we can see box plots of emotional self-ratings before and after the session, split by two groups. Each box plot represents a different emotion, such as enthusiastic, excited, interested, calm, irritable, distressed, upset, anxious. They are rated from 1 to 5. At first glance, there are some visible shifts in emotional patterns before and after the sessions. You can see it on the slide. However, these box plots are not really statistically representative, so that's why we should apply formal statistical testing. Next slide. Since our data wasn't always normally distributed, we used non-parametric statistics such as Mann-Whitney U-test for significance and Cohen's-d for effect size estimation. And in the Remy visual group, we observed a highly significant increase in emotion interested with a strong effect size. Other positive emotions like enthusiastic and excited also increased, while distressed and upset decreases with moderate effect size. It is a meaningful discovery in terms of reminiscence therapy. On the other hand, the Remy non-visual group in the Remy non-visual group, the changes in positive emotions were not statistically significant, and the reduction in negative emotions was also less noticeable in the non-visual group. Next slide, please. Next, we explored whether the time a user spent with the chatbot had any relationship with their emotional outcomes. Spearman and Pearson correlations tests were applied. The results showed us no statistically significant correlation between conversation duration and changes in emotional state. And it can be possibly explained by high variability for each individual. Some users may need up to 5 minutes of interacting with chatbot, others 10 or more. Next slide. In this section, we analyzed how participants rated the personalization of the chatbot, the ease of navigations, and how likely they were to reuse it. Using the man-witness U-test, we found that users were significantly more likely to reuse the chatbot with 3D visualization of their memories. However, visualization did not significantly affect navigation and ease of personalization, which was quite expected. Next slide, please. And lastly, we looked at open-ended feedback from users. From sentiment analysis, users gave slightly more positive feedback for the REMI visual version, especially when describing what they enjoyed most about the experience. However, talking about suggestions, responses from about REMI visual tended to be more neutral or critical, which may reflect that expectations were higher for the visualization. NLP analysis also revealed that users actively noticed and mentioned the visuals in their feedback. The most common suggestion was to improve the quality and relevance of the memory visualization. Next slide. To summarize our key findings, a 3D visual reconstruction made a significant positive I hope I'm not out of time already.
I think you are. I forgot to time, but I think you are out of time.
Sorry, it's
Yes.
conclusions. And to summarize our key findings, 3D visual memory constructions made a significant positive difference in how users felt during session with chatbot. Participants who used REMI visual felt more interested, enthusiastic, and excited, and it plays a crucial role in the effectiveness of the reminiscence therapy. As the more emotionally engaged and interested users are, the deeper and more meaningful their memory recall tends to be, and they are more willing to participate in the next sessions. There is no strong dependency between session duration and how users felt emotionally after it. Visual users often mention the quality of visualizations. However, their feedback was very different. For example, you can see that one user said like visualization didn't match, another said nice visualization. Last future work is planned to increase number of participants and ensure greater diversity, conduct gender and age-specific analysis, enhance the quality of memory visualization, and apply deeper statistical analysis. Thank you so much for attention. Next slide. Sorry for being a little bit out of time.
Okay, so thank you very much for the presentation.